YouTube channel. In this episode, we will see what is storage optimized instance. So as we all know, Amazon EC2 has provided 7 type of instances. So storage optimized instance is one of them. Basically, these are the instances designed for workloads that require high sequential read and write access to very large datasets on local storage. Now let me put it this way, wherein audio files, right, music files. So there are n number of music files available over the net. So we have iCloud, we have songs.pk, right? So all these audio files gets accessed by a number of users. So large number of users access these music files on frequent basis. At the same time, these audio files gets uploaded by creator also, right? So for all these type of applications or for all this type of use cases, storage optimized instance are the best choice. Another example would be YouTube, right? So YouTube has a huge amount of data, right? All those videos which are getting viewed by users, and at the same time there are YouTube creators also, so they keep on uploading those videos, right? So these are the here basically we are reading and writing data at the same time. Now what I mean by sequential read and write access here is per account, per user will be able to upload data one time, wherein suppose some data is getting uploaded, right, from my YouTube account. Suppose I am uploading one video file, so till the time that video file gets uploaded, I will not be able to upload another video file, right? So this is basically a sequential read and write access, right? Now storage optimized instance comes with 3 series, that is D, H and I, right? So whenever you see any instance starting with D, H or I, that is a part of your storage optimized instance, right? So under D, D2, D3, D3 EN, H, H1, I has got I for MGN, IS 4GN, right? So let's see D2 series. So these instances are well suited for the following: a massive parallel processing data warehouse, MapReduce and Hadoop distributed computing, log or data processing applications. So for all this series, like let me come back to my previous slide, D, H and I. So all this series use cases would be same, but the difference comes for that virtual CPUs and RAM, right? So D2 has come with 4 to 36 and RAM is 30.5 GB to 244 GB. Now if I come to D3 Gen series, very ideal for file storage workloads such as GPFC and BFS, large data lakes for HPC workload. Here virtual CPUs 4 to 32 D3 and RAM is 32 GB to 256 GB, right? So these are the D3 and D3 Gen. H1 series, these instances are well suited for the data intensive workloads such as MapReduce and distributed file system application requiring sequential access to large amount of data on direct attached storage. Now what I mean by direct attached instance storage, the way we have our hard disk attached in our laptop, right? So these are the basically known as a direct attached instance storage. There is a EBS storage also. So EBS is basically elastic block storage, wherein your storage is at some other place, right? So in case of direct attached storage, where your hard disk is attached to that particular local machine or laptop, the latency time will be less, right? So the data will get accessed easily because it has been attached to your system locally, right? Now applications that require high throughput access to large quantities of data, because they need a high throughput access, right? Because the quantity of data is large, and need is to access this data with a very low latency, right? So for that H1 series is one of the best choice. Also the local storage, if you see in H1, it comes to 16 terabyte, right? So 16 terabyte, good, very good storage it comes with. Also virtual CPUs 8 to 64, RAM 32 GB to 256 GB, right? That is H1 series. I for I series, these instances are a great fit for database such as MySQL, Oracle DB, Microsoft SQL Server, and NoSQL databases such as MongoDB, Couchbase, Aerospike, and Redis, where low latency local NVMe storage, right, is needed in order to meet application service level agreement. So they comes with the storage Nitro SSD hard disks, right, with the lower TCO, fast application performance, maximize storage efficiency. So all this storage optimized instances, right, so they just get varied from virtual CPUs to RAM and storage, and at the same time when you look for some high series, the cost is high, right? So please keep that in mind whenever as a solution architect you are suggesting storage optimized instance. So please keep that in mind, wherein the if you are going to choose a very high end machine, so the cost will be high as well, right? i4i we have already talked about. IM4GN series, these instances well suited for workloads that require high random input output performance at a low latency. Relational databases, NoSQL databases, search, distributed file system, virtual CPUs, 2 to 64, RAM 8 GB to 6 GB, storage NVMe SSD. The next is IS4 Gen series for NoSQL. Again, same NoSQL database, indexing, streaming, caching, warm storage. The reference comes here for with the virtual CPUs, RAM and storage, right? So that's it. I wanted to cover about storage optimized instance. So please subscribe to my channel if at all you like the video content, and do watch out the space for more videos. Yeah, thank you.